You could say that number one, I gave you a red herring for when we were going over stuff. You don't have to have a volume. You can use an imaginary 100 milliliter sample, and that's what I had you do there. So for the first one, if we had 100 milliliters and we're assuming that volume is pretty much all water, 1 milliliter, 1 gram, and in every 100 grams of water, we have 70.0. Well, actually, you know what? And this one's terribly. Oh. Okay, so we know that for every 100 grams of water, we can dissolve 70 grams of iron 2 chloride. And, of course, the way this chart is written, and I didn't create the chart. I may go through and fix some of the sig figs, though. So that means we have 70 grams of iron 2 chloride in every 100 grams of water. Well, let's figure out how many moles of iron 2. And you know what? It would probably be more elegant to do this as a single factor label and say, okay, that means we have this many moles of iron 2 chloride in every 100 grams of water. I didn't. I broke it up into two. 126.75 grams iron 2 chloride in 1 mole. So we have 0.552268, etc. Whoops, almost did it myself. Moles of iron 2 chloride. And if we made this up as an imaginary 100 milliliter sample, we're saying we've got 100 milliliters of solution. So when we do our molarity equation, I just left all my little 2's there. When we do our molarity equation, molarity is equal to moles over liters, or moles over volume. We have our 0.5522, etc., over 0.1 liters. So that 100 milliliters would be 0.1 liters. So we get 5.522682 molar concentration. Well, based on that 70, we're going to go ahead and honor sig figs from the table. That gives us 1 sig fig to play with, and that would give us a 6 molar solution. So 6 molar solution. Unusual that we'd have 1 sig fig to play with, but sometimes that's the way it goes. Okay, for number 2, we want to know if a 2.5 molar iron 2 bromide solution at 50 is saturated, unsaturated, or supersaturated. Taking the elegant approach suggested by a student, we know that for every 100 grams of water at that temperature, we can dissolve 144 grams of iron 2 bromide. I'll go ahead and make this one factor label just to sort of help myself out. We know that in 1 mole of iron 2 bromide, we have 215.65 grams of iron 2 bromide, which means that in 100 grams of water, and this is, mind you, what I'm doing here is figuring out the molarity of a saturated solution, and I'm going to compare them. So the molarity of in a saturated solution, we would have 0.6677486 moles of FeBr2, and I'm going to make a note to myself in saturated solution. Well, then what would be the molarity of a saturated solution? And I'm going to make a little notation to myself like that. The molarity of a saturated solution would be, well, 0.66774 blah 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 moles. And here's the part you want to be careful on. In how many liters of water? 0.1. And this is where a few people put in the 100 milliliters or the 100 grams, and that'll, like I said, that'll send you for a loop. So we find that the molarity of a saturated solution would be over 6. It would be 6.67748, etc., molar. So 2.5 is way unsaturated. A 2.5 can still absorb quite a bit of solute. Okay, what's the molarity of a saturated solution of iron 3 perchlorate at 0? Again, probably more than one way to start this, but let's go ahead and look at what a saturated solution would contain in terms of moles of our solute. So in 100 milliliters of water, or 1 milliliter, has a mass of 1 gram. Well, in 100 grams of water, we can dissolve 289.0 grams of iron 3 perchlorate. If we go ahead and just carry that out and do it as one big factor label, then we can say that 354.2 grams of that iron 3 perchlorate which is 1 mole. So we can say that in 100 milliliters of solution, or in 100 milliliters of water, we're going to have 0.815923 moles of iron 3 perchlorate. So now we can look at what is the molarity of that solution. So the molarity of a saturated solution, well, we have this many moles. I'll just move that down. Why reinvent the wheel? And we were dealing with 100 milliliters of solution, so in 0.1 liters. So what's that give us? 8.15923.207 molar solution. We have 3 sig figs to play with coming from the chart, so 8.16 molar. Again, pretty concentrated. Saturated solutions tend to be pretty concentrated. Okay, good with those? Molarity equals moles per liter. We're told that we have, or we're assuming we have 55.49 grams of calcium chloride in a 2-liter bottle of solution. What's its molarity? Well, do we have everything we need here? This is what we want to solve for, our molarity. We have the molarity equation. We want molarity, we have a volume, and we have a mass, so we need to get our moles through a factor label. So if we have 55.49 grams of calcium chloride, we know that there are 110.98 grams of calcium chloride. Okay, so we've run out of time, but the key will be available on the wall outside my room, and if you've got questions, you'll just have to come see me. Homework due tomorrow, test Thursday.